and do a couple questions here and there. Fallon, could I ask you to turn off the lights? So I'm not going to do section A because we looked at that yesterday at expanding, but if you have questions, you'll come up to me later. So let's look at one question here from section B. Okay, so in this question 1, this page, the whole goal of these 3 steps, the goal is step 3, which is determine the equation of the line in y equals mx plus b. Not sure if you noticed that these points are the same, right? It's just like 3 different steps for the same points. But I will choose points that have negatives just in case. All right, step 1, determine the slope using the slope formula. So the slope formula is on your formula sheet. The y's are on top, right? What I do is that I label my points just so I don't make a mistake. So I'll call this one x1, y1, x2, y2. Doesn't matter which one is 1, which one is 2. Okay, doesn't matter what order as long as it's the same one. Okay, so I've labeled my points and now I substitute the values into the formula. So what's my y2? In this case, it's minus 7 minus y1, so minus 3, x2, and here's the tricky, minus x1, so it's minus 1, right? And so when I am subtracting a negative number, that just turns into a positive, right? So it's really negative 7 minus 3, negative 10. 4 minus 1, that's like 4 plus 1. And then I feel pretty good because my slope is an integer. It's not always going to be an integer. Sometimes you'll get a fraction, but it's just easier to work with an integer. So then I move on to the second step. The second step is to find the y-intercept, right? If I want an equation, I need the m and the b. So the m is the slope, got that. In order to find the b, right, for this step, we're finding the y-intercept. Well, I'll start out by writing the equation, but substituting in my m. For these 2 points, the slope is negative 2. Now, critical thinking. I've got an equation. How many unknowns do I have? 3. For one equation, what's the maximum number of knowns I can have? Sorry, what's the maximum number of unknowns that I can have? 1. So I need to find some values. Well, I've got a point. I've got 2 points actually, and that would cover the x and the y. And I get a lot of questions of does it matter which point I use? Folks, when I have a line on a graph, how many points does this purple line have? How many points? No, how many points does this purple line have? Like on the graph, an infinite number of points. How many y-intercepts does that line have? Right. So it doesn't matter which point you use because every single point on this line must result in the same y-intercept. So I'll use the one that looks easier to me. Okay. I'll use y is 3, x is negative 1. Right? So I'm just subbing it in. And then I call it do the math. So expand and simplify. Okay? I've got to do negative 2 times negative 1. So 3 equals positive 2 plus b. Right? I'm simplifying using the rules of Bedmas, using the orders of operation. So bring the 2 to the other side. 3 minus 2 equals b. And so I get that b equals positive 1. Okay? Am I ready to write the equation of the line? Yes, I've got the slope and I've got the y-intercept. So step 3, write the equation using the form y equals mx plus b. Now, the equation of a line must have a y and an x, right? You don't substitute anything there at the end. Now, we're just subbing in the slope and the y-intercept. This is the final product. That is the equation of a line. Got it? Questions? Great. Moving on. I'm going to do one substitution and one elimination question with you. So let's do question 2. First step. So in this case, I'm told to do substitution. Now, I know that I would like to do substitution because y, actually, I'm going to do number 1, because y is isolated. And what is the coefficient of this y? Which is good, which makes it easier to substitute. So I always name my equations. I just say, this is equation 1, this is equation 2. It helps with communication. Since y is isolated, I can say, okay, y and the left and the right side of the equation are identical. So I can substitute this this right side into this y here. So the way that I communicate that is I'm going to say equation 1 into equation 2. You can communicate it differently, right? You can use actual words, but like this is much shorter and it's very clear. Okay, so I'll write out equation 2. But when it comes to y, I substitute in equation 1. Do you remember this? Is it kind of coming back? A little? Okay. Okay. Why did I do this? Look at that equation that we have right now. How many unknowns do I have in this equation? Just x. Can I solve for it? Yes. That's why I substituted. So use the rules of BEDMAS to isolate x. 21x distribute minus 6x. 3 times 7 plus 21 equals 6. Move all the constants or the numbers to one side and keep the x's on the other side. All right, so I'll move this 21 here. It will be minus 21. And so I get 21 minus 6, 15. X equals negative 15. Divide both sides by x. And I get x equals negative 1. And right here, I want to pause and go back to the question because I forgot to do critical thinking at the beginning. I forgot to think to myself, what is the whole point of this question? Okay. When I have these equations, what do they look like on a graph? Are they a dot, a line, a parabola? What are they? Good. They're a parabola if it says x squared. But if it's just x to the power of 1, I've got a line. How many lines do I have? 2. So what happens to most times when you have 2 lines? They're going to cross. What is that dot called? The P. So it could be called the solution. On the graph, it's called the point of intersection. Is that term familiar? Okay, I call it the good old POI, just because it's so cool, right? The point of intersection. So what is the purpose of this question? It's to find the POI. This is why I'm working on this question. This is the goal. What does a POI look like? Well, it's a point on a graph. And that means that it's going to have an x coordinate and a y coordinate. And that's important because then I understand if I know I'm looking for a POI and that means I need an X and a Y, it's like, oh, I need to get two numbers. So that when I get to this point and I'm like, oh, X is -1, I don't stop. I'm like, I've got half of what I need, right? I go back, I'm like, no, I need a Y as well. So to get the Y, I'm going to sub X equals -1 into, I'm going to choose equation 1 because it's already lined up nicely. The Y is isolated, but you could have chosen equation 2 and it will work as well. So I've got -2 times X plus 7. Let's simplify. It's going to be 2 plus 7, Y equals 9. Once again, I go back to the beginning of the question and I say, what was I supposed to do? What was I supposed to find? Oh, the POI. Because if you leave your question like this, you actually haven't answered it. You're like, you found the X and the Y, but you're not communicating that you actually understand it. So our final statement will say POI is -1, 9, right? This is a complete solution. Or another word instead of POI is the solution is, right? The solution to this linear system is -1, 9. This is a beautiful solution, well communicated, clear. The final answer is stated clearly. Elimination is just another way, another tool to solving a linear system. Now, when I say a system, that means we've got more than one equation. A linear system could have 3 equations, right? But we're just working with 2. Okay, now I've got elimination. What am I eliminated? I want to eliminate X or Y. Because currently I have equations that have 2 unknowns and I know I can't do anything about that. So I need to get rid of one of them so that I can have one equation with one unknown. Now, elimination is the right tool for these equations because I notice that the x's have the same coefficient, 6 and -6. And so if I take these 2 equations and I add or subtract them, I can get to 0x, which is gone, which is basically gone. So here's the question, folks. Am I going to add these 2 equations or am I going to subtract them? That's right. 6 plus -6 gets me to a 0. So what am I doing with these 2 equations? I'm going to add the x's, add the y's, add the constants. Okay, so when I add the x's, I get 0x. But when I add the y's, -3y plus 2y, I end up with -1y. And then the equal sign comes up. And then when I add the constants, -6 plus 21, I get 15. Now I don't want to know what -1y is. I want to know y. So I divide both sides by -1. And I get that y is 15. Thank you. -15. Now, what am I doing? What's the whole point of this question? What am I looking for, folks? Say it out loud. POI. So if I have just the y, I'm halfway done. Right? Now I need to find the x. And so in order to do that, I'm going to name my equations 1 and 2. I'm going to sub y equals -15 into one of the equations. I'll just choose one. Could have chosen 2. So I've got 6 x minus 3 times negative 15, right? I subbed in the y, equals negative 6. Six x plus 45 equals negative 6. Bring the 45 over, so we'll subtract 45. 6x equals negative 51. Divided by 6, divided by 6. X equals, I don't think 51 goes, does 6 go into 51? It's 8.5. So in that case, we can either write negative 8.5, which is probably best if we're graphing it, or we could reduce the fraction to be, I think, negative 17 over 2. But in this case, using a decimal is fine because we want to actually be able to visualize where that point of intersection is. POI is negative 8.5, negative 15. Now, can I make a correction in this third elimination question? No, I made a mistake somewhere. Oh, I did. I corrected it in mine already. See here, there's a plus. You have an equal sign on yours. So can you just change it? It's 3x plus 2y. The second thing I want to change is in part C, when I say choose a method, this second question, I actually erased it because it was so ugly. It gave, like, it's doable, but it gives you a really ugly fraction, and I'm just not going to make you do that. That's not necessary. Okay, so cross out that second question in part C. So that's basically how we do elimination substitution. Then we've got a word problem here where you are given, this is like we're sort of building on our skills. First, we practiced how to find the solution or the point of intersection. Now I give you an application question, a word problem. I'm planning a huge birthday bash. Woo-hoo-hoo. Do you think you'll be invited? Sorry. I'm kidding. Of course you're invited to my birthday party. What do you think you're going to do here? You're given equations. You're going to find the solution, right? Read what the variables are. Try to work it out on your own. You could also try to graph them if you wanted. Okay, I'm not. Now, this is interesting. You are asked to determine the number of guests needed to make the cost of each venue the same. I want to sort of show you what's going to happen. Okay, I'm not going to answer this question for you. The y-axis is the C, which is the cost, and the x-axis is the G, or the N, G, which is going to be the number of guests. And then watch what's going to happen. If you were to graph these two, because both of them have a flat fee, they all have a y-intercept, right? And if you were to graph them, there would be a point of intersection. And at that point of intersection, the cost is the same for the same number of guests. Right? So it's like, so here's the question, folks. Let's say this number of guests is 15, and let's say it's like, I don't know, $200, right? So both venues, I'm just making this up, but both venues cost $200 when you invite 15 people, okay? Now here's the question. If you invite less than 15 people, which color, the blue or the pink, which color is the better option if it's less than 15, right? Because, so we want to have a lower cost. We want the cost to be lower. So if I have fewer than 15, I'm going to choose the blue venue. What if I have more than 15 people? Well, I'm going to choose the pink venue because in that case, that one is going to be cheaper. So there's no perfect answer in this case because it's like you can't just say which one's better. You can say, well, if you invite 15 people, both venues have the same cost. If you invite less than 15 people, the blue one's better. If you invite more than 15 people, the pink one's better. Does that make sense? So some critical thinking there, right? And then I want to look at, so in this question, now we build on it even more, right? So now this is the hardest question in this series because in this case, I don't give you the equations, right? So now it's like, oh, I have to come up with an equation and apply my knowledge of linear systems to determine under which condition each magician offers the better deal. Right? So this is when I just have to do everything. So it says, remember to define your variables. How do we do that? Let statements. Okay. So here I'm told Miss Sly is inviting a magician to her math class. Isn't she great? Yeah. So cool. So mathgician, that was good, eh? Came up with that on my own. Costs a flat fee of $360 plus $8 per student. Right? So I need to think about what types of variables would I have. Right? So I'm going to need two variables because we're doing a linear system. So I'm going to need kind of like an X and a Y, but I'm going to call them something else. Yeah. What, you didn't have a question? Yeah. So folks, what is one of the variables that I need to choose from? Sort of like, what are the things I don't know? Okay, so in this sentence, the total costs includes a flat fee of $360 plus 8 per student. What's one thing I don't know? The total cost and the amount of students. Thank you. I don't know the total cost. Give me a letter for it. C. Ooh, excellent. T or C, great. So I'm going to write let C rep or represent total cost. And then for the number of students, what should I use? I'm going to use N so that I don't forget. Because if you just say, listen to this, this is not correct. If you say, let S represent students, that is actually incorrect. You're not, is it like how tall the students are? How pretty they are? How smart they are? No, we want to know let N represent the number of students, right? So number of is important. You could call it S, but you have to say let whatever the variables represent number of students, right? This number of is critical. Got it? And then you're going to set up your equations. What would be the equation for the mathgician? Well, the total cost equals the flat fee plus $8 per student, right? So I have to multiply. Well, if I have 10 students, it's going to be 10 times 8, right? So you would write your equations. And then you would solve your equations. And then I gave you some hints in terms of how to answer this question. Now, I'm not going to actually do it with you because you have the solutions, right? I just wanted to sort of set you up. And then I give you another question that you can work on. Lastly, we have properties of quadratic equations, right? So here, we're not solving quadratic equations. We're not finding the roots. We're not completing the square. We are just discussing the characteristics of a parabola and then putting it on a graph. That's all this question will ask for.
So we don't have to
Not today, right? I'm not even sure we have to do it tomorrow. If you don't have to do it in the booklet, then you don't have to do it. Okay. All right. So let's choose one. Let's do this third one as an example together. Okay. So before we even do it, let's do our kinesthetic work. So give me with your hand a parent parabola. What is the equation of a parent parabola? Y equals x squared. No transformations. Okay. Now, you're going to learn, I forget if I said this or not, but the first transformation, you do RST. That's the order. So you're going to do a reflection, then a stretch, then a transformation. So question 1, is there a reflection? Look at that equation. Yes or no? How do you know it, folks? There is a reflection. What on that equation tells you there's a reflection? The minus. Okay, give me a reflection. I'm so sad. Okay. Next, stretch. SRST. Stretch or compression. Is there a stretch or compression? Yes. What is it? Compression. Okay. How do we know it? 0.5. So show me what that looks like on your parabola. Right? It opens up. It widens because it's like I go, right? I compress it. So it opens up. And now my translations. So I'm going to move horizontally and vertically. Go ahead and do this. Everyone, give me your hand parabola. Come on, everyone. Go ahead and move. Okay, I'm going to go there, and I'm going to go there. Okay, how much did you move? Did you move left or right? Is it left or right, folks? Or sorry, let's just say, are you moving in the positive or negative direction? Negative. How many? 4 negative. Are you moving up or down? Up. Right, so to the left, like negative, and then up. Okay, so now that we know what our parabola is looking like, we can answer these questions fairly easily. Direction of opening, down. Okay, read this question carefully. Stretch or compression, and by how much? So we said there's a compression, and we have to give that factor. By how much is it? It's by 0.5. Okay, that's the compression factor. It's telling us it's being compressed by half. Right, because the negative is not talking about the compression or reflection. I won't mark you wrong if you put it in there, but I want you to, but it's our true level 4 plus understands that the negative talks about the reflection and the number value talks about the stretch or compression. Where is the vertex? Guys, I was looking at the wrong one. Dang. It was 4 in the positive direction and 2. I was looking at the wrong variable. I'm sorry. Okay, axis of symmetry, that's always talking about the x. Now, you can't just write 4. You must write the entire equation. Okay, then the next box is, do we have a max or a min? So if it's opening down, we have a max. Then state the value of the max or the min. Watch how you're going to lose a mark. Alex, watch this. You're going to lose a mark if you say that the max is this. You will lose a mark. That is not true. The maximum value is just the y. It's telling us how high it is. I don't want to know the location of the maximum. I want to know the actual value. Yeah. If you write 2, cool. If you want to really get that 4 plus, you're saying y equals, right? Because you're saying I really understand. Okay? Lastly, let's graph this. Okay, and you can use any method, but I would encourage you to graph using the step pattern. Okay, so in this case, if I'm graphing it, I know the vertex is at 4, 2. 1, 2, 3, 4 across, 2 up. This is my vertex. I'm being asked to label it, right? 4, 2. And now the step pattern. I got to write this on the side. If A equals 0.5, that means the step pattern can be found by multiplying it. Do you remember this? 1, 3, 5, 7, 9, blah, blah, blah. And I multiply that step pattern by the A. So 1 second. So my step pattern becomes 0.5, 1.5, 2.5. And now, of course, I've got that reflection. So add a negative to each of them, right? I should have written negative 0.5. How do I use the step pattern? You always move one horizontally. The step pattern is telling us how much to move vertically. So 1 horizontally, down 1/2. And I'm automatically going to draw the reflected, like the mirrored point. 1 horizontally, 1.5 down. And we're asked to label, how many points did I say? 4 more points. So it's annoying, but I'm going to label them, right? 5, 1.5, 6, 0. And folks, I'm going to keep going until I exhaust my graph. So I've gone down 1.5. Now I have to go down 2.5. After 2.5, how many am I going down? Look at the pattern. 3.5. So half, 1, 2, 3. After going down 3.5, I'm actually going down 4.5. So I pretty much run out of space. But I'll just put that dot there so that I can really beautifully trace my dots. Add arrows at the end of your graph. Oh goodness, this is ugly. Label the graph, write its name, y equals negative 0.5, x minus 4 squared plus 2. I always write that near the arrows. I don't know, that's my preference, but whatever. And then I'm like really glad that I brought my highlighters to Culminating, because I highlighted that I have to label the vertex, that I have to label the axis of symmetry, 4 more points, and the equation. Thank goodness I highlighted that so that I don't forget. So the axis of symmetry is a dotted line, folks. It is not a straight line because it doesn't actually exist. Right? It's a reference line. So I draw a dotted or dashed line through the axis of symmetry. You can use a highlighter. And then I label it x equals 4. Questions here. As I've stated, if you can complete this entire booklet with ease, then you have all the skills and tools to complete the Culminating day 1 with ease. Okay?